right, starting with number 25 on the key. We have log base 3, 5x minus 1 equals log base 3 of x plus 7. So since these two things here are the same, that means that 5x minus 1 is to equal x plus 7, which means 4x equals 8, and x equals 2. There you go. All right, so on this one, we are going to solve for z. So if I want z by itself, I got to get everything away from it. So I'm going to start by moving this first. So I'll subtract it from both sides, which means that'll give me 10y times z equals negative 4x. And then to get z by itself, I'm going to divide both sides by 10y. So z equals negative 4x divided by 10y. Then I can reduce that, and we get that z equals negative 2x over 5y. All right, so then on 27, we are going to solve for y. So I need to start by factoring it out. So when I factor out the GCF here, I get y times 3x plus 1 equals 15. And then to get y by itself, I can just divide. So y equals 15 divided by 3x plus 1. All right, 28, I'm solving for r. So the first thing I need to do is get it out of the denominator. So I'm going to multiply both sides times 1 minus r. So this is going to give me s times 1 minus r. When I multiply this side times 1 minus r, they cancel out, so that's just equal to a. Then I'm going to distribute that in, and I get s minus sr equals a. I'm trying to get r by itself, remember, so I'm going to move this s over here. I get negative s times r equals a minus s. So then I'm going to divide both sides by negative s, and that's going to give me that r is equal to a minus s over a negative s. So can I cancel those two out? What do you think? Heck no. Right? Or I could say, put equals or either one. If I want this to be positive, then I can multiply this whole thing around and get s minus a over s. Or if you want to go ahead and split this, you don't get to cancel that out, but I can split it into two fractions. So s over s would give me 1, but it's still minus a over s. So there's a couple options there. So now I'm looking at domain, and it clearly says in interval notation here. So I've got f of x equals equals the square root of x minus 6. So the graph here, the square root curve, looks something like this, but it's going to get shifted to the right 6. So it looks like this. Right? So we're right here at 6. My domain is my x values. It includes this 6, so it's going to go from 6 to infinity. Okay, so then here, f of x equals x plus 2. So x can equal anything except what's going to make this 0, right? So I know that x plus 4 cannot equal 0, which means that x cannot equal negative 4. So my interval then is going to go from negative infinity to negative 4, and then from negative 4 to positive infinity. And that is a union of the two, not an intersection. All right, 31. In order to simplify this, I'm going to have to factor the denominator, and that is a difference of 2 squares. So this is equal to, I'm sorry, I'm totally not trying to solve this. I'm trying to find the domain. So here's what I know about the domain, is that x squared minus 9 cannot equal 0. Still got to factor it, but my brain was somewhere else. So I know that x minus 3, because this factors into x minus 3 times x plus 3, that cannot equal 0. So x minus 3 cannot equal 0, and x plus 3 cannot equal 0, which means x cannot equal 3, and x cannot equal negative 3. So I can start at negative infinity, can go to negative 3. Then I can go from negative 3 to 3, and then from 3 to infinity. That's a union of those. So it just leaves out those 2 points. Okay, so I know here on 32, the denominator can't be 0. We know that. And then also we cannot have a negative under here because we don't want anything imaginary. So what I know has to happen is that x plus 2 has to be greater than 0, which means x has to be greater than negative 2. So in interval notation, it can't be negative 2. I can go from negative 2 to infinity. So I'm going to state the domain and range in interval notation. See the graph. So on 33, I've got this graph. There we go. I knew it was going to jump. So my domain, which is my x's, okay, this is going to keep on going. There's nothing that's going to stop it on that side, and nothing that's going to stop it over there. So this is going to be negative infinity to infinity. My range going up and down, so the left and right there was negative infinity to infinity. There's also nothing stopping and going the other way, so negative infinity to infinity there as well. Okay, so 34 rather. Not going to touch 0 in either direction here. So my domain for my x's, 0 is not included there. So this is going to be negative infinity to 0, and then 0 to infinity. Then for the range, same thing. Just can't cross there. So negative infinity to 0, and 0 to infinity. That's it on that page. Alright, so here we're going to state the inverse of each function, tell whether the inverse is a function. So in order to do this, I am going to change f of x to y, so I'm going to get y equals 1/3 x plus 7. Then I'm going to switch my x and y, so that's going to give me x equals 1/3 y plus 7. I'm going to clear my fraction, so I'm going to multiply every single thing by 3, so that's going to give me 3x equals y plus 21. That means that y equals negative 3x. No, it doesn't. Oh, my goodness. Y equals positive 3x. Making things up, seeing if you're paying attention. Okay, so y equals 3x minus 21. That is a graph of a line, and so a line is a function, so this is what we have, and our answer is yes. Alright, so for the next one, this is going to give me y equals x cubed. So then I'm going to switch x and y to get x equals y to the third. So to get y by itself, I'm going to have to take the cube root of both sides. So y is equal to the cube root of x. Cube root, graph of the cube root is a function. So this is a yes. Okay, so then here, this is going to give me y equals x squared plus 4. Then I'm going to switch x and y, so I get x equals y squared plus 4. So then I have to solve for y, and that's going to give me x minus 4 equals y squared. Then I'm going to take the square root of both sides, which means y equals plus or minus the square root of x minus 4. So this is a no, because it would basically be, this right here is going to move it over, so it's going to give you the top and the bottom, and it's not a function. Okay, now that says graph the following quadratic equation. Determine whether it opens up or down. Find the vertex and determine if it's a maximum or minimum value. Find the x and y intercepts and the domain and the range. Okay, so here's what we know. We know that since the